So under isomerism, we were discussing the optical isomerism. The last class we have completed the optical isomerism in tetrahedral geometry with monodentate ligands and also tetrahedral geometry with bidentate ligands. That to be in bidentate ligands in tetrahedral geometry, structurally unsymmetric ligands. What I given two ligands I have given. One is benzoyl estone ato and salicyl aldehyde ato. We have discussed some boron and beryllium complexes with bidentate ligands, tetrahedral complex of beryllium and boron we have discussed. Now we will see now the coordinates number 6 in octal geometry, how this optical isomerism. Coordination number 6, octahedral geometry, octahedral geometry. So first we take octahedral geometry with monodentate ligands. Octahedral, I am writing like this, octahedral with monodentate ligands. Octahedral with monodentate ligands. First type let us consider types under this. First one. Take Ma4B2. Or you take Ma3B3. Either you take Ma4B2 or Ma3B3, both of these complexes with monodentate ligands. Either you take cis isomer or the trans isomer. Cis isomer and trans isomer of both of these complexes are found to be symmetric. We can cut into equal halves. Symmetric. So they are obeying all these symmetry elements, either plane of symmetry, center of symmetry, axis symmetry. These are symmetric complexes. Either you take cis or trans geometries. Therefore, these two models, these two are not exhibiting optical isomerism. So, no optical isomerism due to symmetric geometries. Because of cis and trans both are found to be symmetric, therefore no geometrical isomerism, symmetric geometries. Because these are symmetric, therefore no optical isomerism. Coming to the second, take now Ma2 B2 C2 you take plus or minus n. Let me give real example. You take one. Consider CO, take NS3 taken twice, and Cl2 let me write, H2O taken twice, Ma2 B2 C2 you consider. This is what Cl2, therefore plus charge is enough to make it cobalt plus 3 to the complex. Recollect what we have discussed about this particular complex. For this particular complex, 5 geometrical isomers are possible I have given, but out of these 5 geometrical isomers, now 3 are isolated I said. Theoretically 5 geometrical isomers are possible, clearly given already. Out of these 5 geometrical isomers, 3 are only isolated I said. Among this particular 5 isomers, the cis isomer is unsymmetric. I will write the cis isomer and I will show how it is optically active. See, only cis isomer found to be cis isomer unsymmetric. This can only exhibit optical isomerism, optically active. Only cis isomer unsymmetric. Let me write here instead of writing that one, let me say it is optically active. optically active. Let me show this particular cis and how this is optically active.